We're going to talk about section 5.6a, and we're going to find the inverse of a matrix. But before we do that, let's go ahead and look at this warm-up. It asks us to use our calculator to solve this. So when we're doing this, when we did it on our assignment and our notes last, we started by making the augmented matrix for this system. So we're going to take all of our coefficients and our constants. I want to see that augmented matrix. And now we're going to put this into our calculator. So going to second matrix, we're going to arrow over to edit. We still have 3 rows, but we only have 4 columns. So for me, I need to change my dimensions to say 3 by 4. And then I can type in all of my coefficients and my constants. Be careful as you're typing these in. You don't want to get a wrong solution because you've mistyped in. So be really careful, especially if there's negatives involved. So we learned in the last video that we can find the solution to this by going to our matrix menu and still arrowing over to math and using that up arrow to get there a little bit faster. But we use this RREF, which we remind ourselves it stands for reduced row echelon form. So this is telling the calculator to solve using our row operations that we've been using. So we call matrix A that we've entered, and we get our solution matrix. So using our calculator, we got the identity matrix, which we know gives us our solution. And in this case, it gave us the x value of 1, the y value of 2, and the z value of -1. So we'll just write those in as an ordered triple to finish off this problem. So it's really nice when the calculator can help us do these types of problems. All right, let's look below the warm-up and start looking at today's stuff. So it says that 2 n by n matrices are what are called inverses. They're inverses of one another if their product is an n by n identity matrix. So we know what an identity matrix is. We just looked at it in our warm-up. Anything that's got the same dimensions, 3 by 3, 2 by 2, 4 by 4, and that main diagonal is ones. So 2 matrices are inverses of one another if their product, I'm going to underline that, their product is the identity matrix. So not all matrices are going to have an inverse. So most things that we've worked with in math up to this point have an inverse. They have something that undoes it. But in matrices, that's not always the case. So specifically, an n by n matrix has an inverse if and only if the determinant is not 0. So when we get that determinant of 0, we know that there cannot be an inverse. And we'll review that in just a second. And we have some notation, which we did learn last year, but quick reminder. If we have the inverse of a matrix A, we would denote that with A to the negative first power, which we would say the inverse of A. So let's look at example 1 and start using this idea of inverses. It says, determine whether each pair of matrices are inverses. So here's the question we're wondering is, does the matrix A, when multiplied to the matrix Q, does it give us this identity matrix? So this is our question. So we're going to use our calculator to help us multiply this. Last year we learned how to do it by hand, but we're going to go ahead and use our calculator this year, which is super nice, to help us see if this works. So we're going to have to enter both matrix A and matrix Q into our calculator. So I'm going to go to second matrix, arrow over to edit. And this time we do have to do 2 matrices. So we're going to start with matrix A, and these dimensions are 2 by 2. And I'm going to enter in my values. So we have -4 and -4, and then another -4 in that second row, but then a -6. So there is our matrix A. So I have to go back to my second matrix, arrow over to edit. But now I want to down arrow, and I now want to edit matrix B. So my matrix B is going to be this Q one here, which is a 2 by 2 again. Now these are fractions, and you can enter them as fractions, but if they're nice fractions that are converted to decimals, I tend to just put in the decimal. So negative 3/4 is just negative 0.75. So for me, that's a little bit faster. 1/2 is just 0.5. Another 1/2, so 0.5, and then negative 1/2, so negative 0.5. And now I've got both of these in here. So I'm going to go back to my home screen, and I'm going to clear that out. So I entered both of my matrices. Matrix A was in the matrix A spot, but matrix Q was in that matrix B spot. And I would like to multiply those. So I'm going to call each of them to my main screen here. I'm going to call matrix A first. I'm going to tell it I want to multiply that to matrix B. So I want to make sure I arrow down and select matrix B and enter. So when I multiply these two matrices together, if I get the identity matrix, then yes, these are inverses. So that's what the question was asking us, is determine whether each pair of matrices are inverses. So my answer here is yes. When we multiplied them together, and we used our calculator, but when we multiplied them together, we got the identity matrix. So let's try this again on problem B. So again, my question that I'm really thinking is, does matrix S, when multiplied to matrix T, give me the identity matrix? And if it does, then they're inverses. So I need to go to my calculator and enter both of these. I'm going to go ahead and edit matrix A. It's a 2 by 2 again. And I'm going to put in matrix S into this spot. So lots of zeros in this one. And a negative 8. And then I'm going to put matrix T in. So second matrix, arrowing over to edit. But this time I'm going to arrow down to matrix B. Still 2 by 2. And we've got a 0, a 1, and a 0. So almost the identity matrix there. Not quite, but almost. So on my main screen then, I'm going to go ahead and multiply. I'm going to call matrix A that I've newly edited and multiply that to matrix B. So make sure you arrow down to B. Oh, and this time we do not get the matrix. So in this case, no, these cannot be inverses of each other, because when we multiplied them, we did not get the identity matrix. So we know how to decide if matrices are inverses of each other, but let's find the inverse of a matrix. Now this is something that we did last year in secondary 1, so hopefully this will look familiar. So example 2 wants us to find the inverse of each matrix if it exists. So remember, not every matrix is going to have an inverse. And we're going to make sure we show all of our work. So I've got just here to the side in our box a quick reminder of the steps that we learned last year to find the inverse of a matrix. So step number 1, we want to find the determinant of the matrix. So remember, determinant can be denoted by these two, almost looks like absolute value bars. So when we see this around a matrix, this is telling us to find the determinant. So to find the determinant, we take what I call the main diagonal, A times D, when we get that product. And we always subtract, and we subtract the second diagonal, B times C. So we take that main diagonal minus the second diagonal. And as a reminder, as it says above, if it's 0, when we've done this multiplication then subtract, it will not have an inverse. So you can stop right here and you can just tell me there is no inverse. So let's go ahead and try matrix A. I'm going to take my main diagonal, and I like to circle. So let's see, 1 times negative 3, so negative 3, minus that second diagonal, which is 0 times 5. Well, in this case, my determinant when I subtract is a negative 3. So I know that this matrix has to have an inverse because its determinant is not 0. So now I get to go to step number 2. And step number 2 has me doing a little bit of switching around. So I'm going to take this original matrix and I have to move it. So step number 2 says I want to switch the element that's in the A sub 1, 1. So the first row and the first column, so that would be that top corner there, with the A sub 2, 2. So what's in the second row and the second column, which would be this D. So those two need to switch places. So I'm going to go back to my matrix here, and I'm going to switch the places of the 1 and the negative 3. So those are going to switch places for that first piece. And it says we want to multiply the element that's in the A sub 1, 2. Let me erase my circles here. So in the first row but second column, so that would be that upper left corner there, and the A sub 2, 1, so second row, first column. I want to multiply both of those by a negative 1. So I'm going to take my elements. So I'm going to start with my negative 5, multiplying that by a negative 1, and then 0, multiplying that by a negative 1, still stays 0. So for step 2, we do a little bit of switching and multiplying. And now we're ready to do step 3. Step 3 says we want to multiply 1 over the determinant, and then we're going to simplify. So now I need to take my determinant, which was 1 over, or which was negative 3, and I need to do 1 over that determinant. This value, when distributed inside to each element inside of my matrix, is going to give me the inverse. So we will not be shocked if we see some fractions as we distribute here. Negative 1/3 times negative 3, so those are reciprocals. That gives me a 1. Negative 1/3 times negative 5, well, that's going to give me positive 5/3. Negative 1/3 times 0, and negative 1/3 times 1. So this is the inverse of the original given matrix. So how do I know? Well, we can check, just like we did in example 1. I can take the original matrix, so 1, 5, and 0, negative 3, and I can multiply it to my new 1, 5/3, and 0, negative 1/3. If those two give me the identity matrix, then I know that I solved these correctly. If I don't, then something's gone wrong. So I'm going to go into my calculator, into second matrix, and I'm going to put in these two. I'm going to edit matrix A. Again, it's a 2 by 2, and I'm going to put in my original matrix here. So starting with 1, and then 5, and then 0, and negative 3. And then I'm going to enter in my second matrix into that B, also a 2 by 2. So this time I have a 1, and then I have a 5/3. I'm just going to enter it in as 5 divided by 3. And then I have 0, and then I have negative 1/3. So I'm entering it in as negative 1 divided by 3. So on my main page, my home screen here, I'm going to take those two matrices and I'm going to multiply them. And I'm hoping to get the identity matrix, because that would show me that these are really inverses and I had done my work correctly. So I'm choosing A times B, and I see the identity matrix when I multiply them together. So in this case, when I multiplied these together, I did get the identity matrix. So that just checks off for me, yeah, I did that problem correct. So if you're ever not sure, we can just multiply the original matrix to what you think the inverse is. And if it is really the inverses of each other, you'll get that identity matrix. Let's try B. So again, first step I want to do is go back to finding the determinant. So I'm going to take that main diagonal, so that negative 2 times negative 6, so positive 12, minus that second diagonal, 3 times 4, which is also 12. Well, in this case, I get a determinant of 0. And as it says right here, if it's 0, it will not have an inverse. And this is where we're going to stop, and we're just going to say that there is no inverse. No inverse exists. So not every matrix is going to have an inverse. So that determinant really is what we're going to be watching for to decide if we have one. Let's go ahead and turn it to the back side. So last year we did spend some time by hand calculating the determinant of a 3 by 3 matrix. And there was two ways that we did this. We did what was called expansion by minors, which takes a little bit of time. It breaks this 3 by 3 into some smaller 2 by 2s. And then we also did do what was called diagonals. We referred to it as diagonals. But this year we're going to need inverses to help us solve in an upcoming video. So we're going to learn how to let the calculator help us do these bigger matrices. So we're going to find the inverse of each matrix, which in this case there's just one, and we're going to use our graphing calculator. So I've got some steps here in our box to help us do this. But the first thing, as always, is we just need to enter this matrix into our calculator. So I'm going to go to second matrix, over to edit. And now, because I need to change my matrix dimensions, because now I have 3 rows and I have 3 columns. So 3 by 3. So let's enter in this matrix. Once your matrix is in, go ahead and go back to your home screen. I'm going to clear out what I already have in there. And so now I'm ready to select my matrix. So I'm going to go back into second matrix and choose that A, that 3 by 3 I just entered. And now there is a button. It's actually a button we've used a lot. Instead of doing second matrix, notice that matrix button is X to the -1. So I'm going to go ahead and press just the X to the -1, and it's going to put that inverse notation right up there next to our matrix A. And if we press enter, it's going to calculate for us the inverse. Now notice it's all in decimals. So remember, we can change these back to fractions. I'm going to go ahead and do an alpha y equals and choose that number 4 to change those back to fractions, and just press enter. And aren't we glad we didn't necessarily have to do that one by hand? That would have been a really fun determinant to distribute to all of these terms. So here's our matrix. I'm going to go ahead and call it matrix A, so I can put an inverse symbol there. Here's my inverse. And I've got lots of fractions, so I'm going to make sure that my matrix is large enough. Be really careful as you're copying them down. Got lots of fractions here. So hopefully you've entered these in correctly. If you did, then the calculator is giving you the correct inverse matrix. But we could still, if we wanted to check, make sure we've done everything that we were supposed to, we could take the original matrix, put it back into our calculator, and this new inverse matrix, and put it into our calculator, and we could multiply these together. And if we got a 3 by 3 identity matrix, then we could just check ourselves to say, yeah, these are really inverses of each other. But this is my solution. This 3 by 3 matrix is the inverse of what we were given. So go ahead and self-assess. How do you feel about finding the inverse of a matrix? And good luck on your assignment.